Show of hands, how many people need more time, or how many people are done? Let's do that. Okay, we'll give a couple more seconds for folks. I will go into that. This is a prefetching step, so we can get things started here. All good, all very good questions that will be answered soon. Who needs a little bit more time? Feel free to raise your hand. Okay. We'll wait 30 more seconds and then we'll move on. Once again, the slides are up on the website to look at. And if you have any issues or if you need any help, feel free to raise your hand and either Jerry or Sagar will come help. Okay, so we've modified this file. f1.2x large is 1, topology is no-net config, no-net num nodes is 1, and our hardware config is now FireSim, Rocket, single core, no NIC, L2, LBP. Let me go ahead and hide this. Okay, great. Okay, so now let's actually do a little bit more prefetching and do the following. So we're going to append the hardware DB entry that we built earlier in the day. If you built it, if not, don't worry about it. You can still run the same command. Go ahead and cd into fdir deploy and run this cat file. Again, tab completion is your friend. There should be an existing entry that has the exact same name that you typed out in the other file called FireSim Rocket single core no NIC L2 LBP. And we're going to do the double arrow here to config hardware db.yaml. Again, tab complete is your friend. You don't need to type it out exactly. You can just click tab once a couple of characters are done. So what we're doing here is after we've built a FPGA bit stream and it now lives somewhere in the cloud with a particular ID, we're actually adding it to the known location, or we're adding it to the location that FireSim looks for these FPGA bit streams. So we're saying that it is now visible to the manager, that FireSim command to run. If you want to, after you've done this, you can look at you can make sure that it looks something like this. Again, it might have a different ID here, depending on what you built. But basically, you should make sure that your config hardware DB file should have something that looks like this. FireSim, again, the long name with some ID and some nulls for the other values. And if you did not build a bit stream from this morning, no fear, we already pre-built one for you. So this file will exist whether you finish your build or not. So you should be able to run this cat command and still do the exact same thing. Anybody need a little bit more time? Okay, great. So this is prefetching some things, and now we can actually start a simulation. So you might already be in a TMUX session or not. Depending, if you're not in a TMUX session, you can create a new one and enter it. If you're not in a TMUX, or if you are already in a TMUX session, excuse me, go ahead and run FireSim launch run farm and FireSim infra setup. So this is basically going to start the simulation and launch machines for the simulation. And I'll talk exactly about what these commands do in just a second. But go ahead and type this. You should start seeing output on your screen, like it's starting to boot some sort of FPGA instance machine, and then it's maybe copying over results. But go ahead and run that command. And you should do this in a TMUX session because later on we're basically, or actually, you should try to do this in a TMUX session. I'll just say that for right now.
It gives a couple of messages that another configuration is overriding the deployed triplet.
That is a warning, so you are good.
Okay.
Yes. Yes, you are good. Yes. That warning is fine. Some help over there? Okay. So hopefully people have run the commands. You should start seeing output on the screen. We'll go ahead and talk about what did we just do, right? We typed some weird things in a file, and then we actually ran some commands, and now this guy up front is telling me that stuff is running, right? So what did we actually do? So as I mentioned earlier before, runtime configuration is managed by this config runtime YAML.file, config runtime file. It's basically indicating to the FireSim command that you typed in, that FireSim infra setup FireSim launch run farm, what I'm going to launch and what am I going to run. So it indicates at the target level, basically what's the network topology, what's the FPGA image that I'm going to use, and what's the actual workload, what's the actual software thing that I'm going to run, the binary, Linux, whatever the case is. And at the host level, it specifies things like, what are the EC2 instances that I'm going to launch the simulation infrastructure on, right? Which EC2 instance has the FPGA? So let's actually dive in a little bit here. So the config runtime file has a couple different sections. First section is this run farm section, and it basically consists of a couple different components. It has this base recipe, which basically indicates what's the provider of the simulation resources, aka the instances that have the FPGAs. In this case, the thing that's providing FPGA instances is AWS EC2. So we basically abstracted all the defaults out into a particular file. It has a bunch of overrides that basically talk about some of the defaults for AWS EC2 instances. Things like, am I going to tag the simulation instances with a particular name? Do I want to use like on-demand instances? If you're familiar with AWS terms, you should understand what these are. It's basically indicating how I want to launch the simulation instance. Finally, at the end, you should see here default simulation dir, which basically means that when the simulation is launched, this is where all the collateral is going to be copied to, and I'm going to run the simulation out of this folder. Next section here, inside of run farm still is basically run farm host to use. This is basically indicating the instances that I'm going to launch for a simulation. So if you see here, there's a couple of different types. There's these F instances, which are FPGA instances for AWS. You have these M and Z instances, which are just other instances on AWS. Varying amounts of CPUs, varying amounts of RAM, whatever the case is. In our case, we set one of the FPGA instances to turn on. So we're actually launching a VM on that FPGA-enabled instance. Next section is this target config. Target config basically indicates what is the actual RTL that I'm going to run and associated things with the target. So for example, if I'm running network simulations, I would specify a topology here. In this case, we're not running something with a NIC, so I specified no net config. In this case, I have how many nodes? I only have one node that's not networked. I have some network configs here, but again, we're not running with the network, so we can ignore that. And then we have our hardware config. This is the bit stream that I'm going to flash on the FPGA that I launched. So in this case, it's this Rocket Quad Core NIC, but you changed it in your slides here. And this hardware DB entry basically references a hardware DB entry that you just catted in. So you catted from built hardware DB entries, the long name into this file. This unique string points to that entry in the hardware DB. Basically saying, this is the bit stream that is visible to me. The next section is what's the software that I'm going to run. We talked about FireMarshal, how do I actually build software and export it out into FireSim. That's what this workload is doing here. So basically, I give it some workload name, which is a definition of a FireSim workload. I'll talk about what that means here. And it's basically saying, I'm going to boot Linux. This is basically going to give me the rootfs and the binary. I'll show you what these files actually look like. It also indicates things like when the simulation is finished, let's say I get a done signal, I finish doing my matmul, should I terminate the simulation instance immediately or should I keep it up and running? And then, of course, more ways that you can tag instances so that you're able to distinguish what's running on what machine. And we'll go into this in a bit, but basically workloads are all provided in this workloads directory. And it's basically in a format or an API that FireSim understands to run that workload. There's plenty of other sections here that we don't have time to go into. Things like meta simulation, tracing, auto counter. And we'll talk about some of these sections in debugging and some of these sections we won't have time to go into. But they basically allow you to add a lot of debug capabilities that FireSim provides. So we went ahead and did this. So again, we already catted this file into config hardware DB, we should have seen that this is what it looked like, and we started running things. We modified things so that we had one FPGA instance that was launched. We made sure that we had a no net topology with one node, and then we changed the hardware config to point to the bit stream that we built in the morning. Then you ran I think there's some help that's needed over here. Then we ran FireSim launch run farm, which actually booted the instances. So this is actually taking the list of instances that you put a 1 or a 0 next to, and it's actually spawning up a cluster for you, a simulation cluster. In this case, you should see something like this. Again, the unique IDs or hashes are going to be a little bit different from your end to ours. That's posted in the slides here, but you should see that one instance was booted in f1.2x large. And this is, again, spawning a run farm. So it's spawning all those instances together. Then you should see an infra setup that is actually building things and deploying them to that machine that was launched. So in the case of that simulation machine, what it's going to do is first it's going to say, I'm going to build all the simulation drivers for that particular FPGA simulation. So I'm going to build all that C++ code that the Golden Gate compiler emits. Then it's going to build a switch model if needed. In this case, we're not running a switch-enabled simulation, a network simulation, so it's not going to do that. And then it's going to start transferring files back to that FPGA instance so that it can run the simulation. So it's going to copy over your workload information, the RISC-V binary that needs to run, the rootfs, and then it's also going to run the FPGA, or it's also going to copy over the bit stream if needed. And then finally, it will program the FPGA with the desired AGFIs, flash them into a known state. I think there was another thing of help that was over here. Sagar, perfect. Okay. So that should already be running. It should look something like this. I don't know if it's done yet. Show of hands, is it done for most people? It's done. Okay, great. Just to go through some of the output here, you'll see things like it's checking that the instance is live. It'll give you the IP address of the instance that was launched on AWS, and it'll do some miscellaneous setup. Again, putting things into a known state, and then actually flashing the FPGA and loading any other FPGA-related collateral, like virtual JTAG to actually flash the thing or start up a hardware server. So a variety of things. And what you might start to notice here is that for all of these logs, if something does go wrong, because sometimes things do go wrong, you can actually get a log of it. So we actually log all of the output that you see to a known location in the FireSim manager, so you can actually go back in time, see what happened, what went wrong, fix it, and continue. So we initialized infrastructure. Now let's actually run something. So now let's run this command. Go ahead and type in FireSim run workload, and we're actually going to spawn a simulation here. So go ahead and type this command, and you should start seeing output that looks like this in 1 second. You can see it. It's checking that the instance is alive. If it knows it to be alive, it's going to start executing basically the binary. It's going to start up the binary. In pictorial form, this is basically what it looks like. The manager is basically going to send a signal out to all the simulation machines. It's basically going to start the FireSim simulation on each. After a few seconds, you should see something like this, which is the simulation report status page. And basically, it tells you a couple things. It tells you where the output might be stored. So when the simulation is done, where the output is going to be. It gives you where this output is going to be logged, again, keeping track of everything. And then it tells you the instances that are spawned, aka their IP addresses. Again, your IP address will look a little bit different. It'll tell you what simulations are running on what nodes. In this case, Linux Uniform is running on that IP address. And it'll basically tell you if something is finished or not. So in this case, hopefully everybody should see this now. So everybody go ahead and look at the IP address that's listed in this, this output. and make sure you keep track of it because we're going to use it to SSH into that simulation machine in just a second. So in tmux, or I guess in another terminal, go ahead and SSH back into your machine, and then go ahead and SSH into that IP address. Basically, do not stop this log that's running. So create a new terminal. If you know how to use tmux, create a new pane, detach, whatever the case is. And in a fresh terminal, through tmux, screen, whatever the case is, go ahead and SSH into that IP address that you saw on the other screen. Again, your IP address will be different. In our case, it was .3.52. Once you do this, you should see kind of an empty console. You should see FPGA dev AMI with some extra stuff, and then a console. At that point, when you're in the simulated node, you can go ahead and type in this command, and you should start seeing Linux booting. So in this case, you're SSHing to, so I'll go back here. Yeah, so in this case, if you're starting out here in a terminal, so you SSH'd into the manager instance, the next SSH command is basically taking you to the simulated node, the node that has the FPGA that's running the simulation. And then at that point, you're running a screen on this node that's basically attaching to the simulation. Attaching to the FPGA accelerated simulation. Yeah, so you're basically hopping from your laptop or whatever the case is to the manager instance. Then you're running that SSH command from that output window to get to the simulation machine. Then you're typing in screen, which is then taking you from like outside of the simulation into the simulation, attaching to the UR console. Good question. So if you ran screen FSIM 0, you should now see Linux output. Who is seeing Linux output? Cool, okay. And who needs a little bit more time to get there? Okay, no problem. At this point, I'll give you a little bit of seconds anyways to mess around. But if you are seeing Linux output, you're actually booting Linux on the SoC that you built, right? So this is real Linux output from a Chipyard-based SoC. In this case, it's a Rocket in-order core-based SoC that's running Linux. You're basically running it in FireSim simulation, psycho-accurately deterministic, and you're actually booting Linux on it, and you can interact with it live. So once you see the console output, you'll see a build root login here. It'll come up after a few seconds of booting the simulation. You can type in the username as root, and you should automatically be dropped into the simulation to a prompt where you can type whatever you want.
Can you go back one slide for the SSH command line?
Yes. So SSH into that IP address that you saw on the other terminal. And then once you're in that simulation machine, you can type in screen -rfsim0, and you should see Linux output. And again, the slides are up online, and we also have wonderful helpers in the back here to come help you out. So once you see a prompt, hopefully people have seen a prompt for a login, go ahead and type in root, and then you should be dropped into Linux. So now it's like any other machine. You can cat files, you can look at random operating system things, your root user, so you can destroy the machine, you can rmrf / whatever the joke here. You can open Vim, you can write a file, right? This is all running on the simulated SoC in real time, psycho-accurately, deterministically. So I'll give you all a minute or two, a couple minutes here so that you can mess around with it. And then once you feel like you're done messing around with the system, you can go ahead and type power off -S, and you will actually shut down the simulation here. So you're terminating Linux boot, or terminating Linux running. So I'll give you all a minute so you can mess around. You can write any files you want to, delete any random operating system files and see if it crashes, whatever you want to do. And after you typed power off -S, you can actually exit out of your existing SSH session, the simulated instance that you're SSH'd onto with Control D or exit, whatever you want to do, and you can return back to the manager instance.
So the first SSH got me into the FPGA host machine.
Correct.
And the screen got me into the simulated machine.
Correct.
Okay.
Correct. Now, in this case, we're working with the simulation interactively, right? We're typing commands, we're typing uname. Normally, you probably don't want to do that if you're scripting up 100 machines that all want to run your benchmarks in parallel. So like in FireMarshal, I mentioned that there was a command field where you immediately run the script or your binary. Basically, if that FireMarshal workload is installed to FireSim and it's run, it will automatically type in that command and click enter immediately when simulation starts. And then it will automatically type in the power off command for you. So you won't have to even enter this like SSH to the simulated machine, type in screen to do anything, to run any command. And in that case, once the simulation finishes, it'll copy back results. Okay. Yes. So in the case for you, I'm assuming you mean post run hook.
Yes.
Yes. So yes, it will also run that as well. Yes. Correct. Correct. So the post run hook is done by the FireSim manager. After it copies back results to the FireSim manager, then it will do the post run hook. Jerry, another person over here. Correct. Because from the view, if you type in power off here, from the view of the simulations perspective, it's still doing the correct thing. It's just terminating Linux. Yeah. Cool. So to kind of dive in here, I'm a little behind on time. But basically, what did we just do? We just booted Linux on our simulated machine. But how did we actually specify this? It was this FireSim workload. So we have a FireMarshal workload, and now we have a FireSim workload. So what does that mean? It's basically the jobs that we're going to send out to those FPGA simulations to run. So we have two types of workloads. We have things that are called uniform and non-uniform workloads. By the name, uniform workloads are, homogeneous jobs that are all sent out to the FPGA simulations. So if you have multiple FPGA simulations, you're sending the same binary out to each. You have a non-uniform one, which is a bit more interesting. For example, you can use it to boot SPEC. So you can send different binaries to different FPGA images, so you run them all in parallel. This is what that workload file looked like. So you had Linux minus uniform inside of your config runtime. If you actually open it up, it looks something like this. This is basically the FireSim schema that indicates what I'm running, how I'm running it, and where, like, what should I copy out of the simulation. So in this case, Linux uniform is using the boot binary. So this is the Linux binary that I'm going to run. This is the rootfs image. And then in terms of outputs, these outputs are going to be copied out from target land. So if I write a txt file, for example, inside of like the Linux prompt, when you were messing around, it would be able to copy that out if you put it here. And then simulation outputs are external to the simulation, in this case, the UART log. So you're able to copy out the UART log, and FireSim has a bunch of other capabilities, but in this case, it also dumps memory stats to a particular file, so you can copy that back as well. So you can see what's happening in the DRAM model. SPEC is kind of a more complicated case. I won't go into too much detail here, but it's basically kind of the same thing. So you basically have the name, you have the things that I'm going to run in particular, or things that I'm going to copy over, what I'm going to copy out, particular commands that I'm going to run so that I don't have to work interactively with the simulation. I don't have to actually type it out. And basically, these are unique to every FPGA image, right? this file is auto-generated for you by FireMarshal. So if you understand the FireMarshal schema, you don't even have to touch this, which is nice. And again, FireMarshal will work on your software RTL simulation or on your functional simulation, whatever the case is. Cool. So I don't think we have time to run MobileNet because I think we have to move on to the next section here. But I'll actually talk about what are some of the commands here. And you'll actually run MobileNet with some debugging features in the next section anyways, but I just won't run it normally. So in this case, for the MobileNet side, go ahead and open up this file. We're not going to actually run the commands down here. We're just going to modify the file. So go ahead and open up fdir deploy config runtime.yaml and go ahead and change the default hardware config to FireSim Gemini Rocket single core no NIC and change the workload name to MobileNet bare metal.json. If you remember back in what we did in FireMarshal, the FireMarshal slides, we installed the MobileNet bare metal workload with the FireMarshal command to FireSim. So now it exists in a location that FireSim is able to read it and understand it. And we're just pointing to it, saying that I want to run it. So that's exactly what I'm doing here. Feel free to open up the MobileNet file if you want to down the line. Correct. But the thing is that we ran it for you, whether you ran it or not. So the file does exist anyways. Correct. So I'm installing it. The FireMarshal basically writes the binary in the rootfs to a FireMarshal local location, local to the FireMarshal directory somewhere. It's called images, but images something something your binary name. When you type in FireMarshal install, it's basically generating a file, this MobileNet bare metal.json file in the workloads directory of FireSim that has all the pre-populated fields for that particular workload. So that's what it means by installing it. It's basically specifying everything that FireSim needs to run the simulation, and it's writing that file out into a FireSim location that it can actually access. Okay, how are people doing with this? Just modifying the file again. Don't type the commands underneath. We're a little low on time. Okay. So what we're actually going to be doing in the next couple sections and parts of the talk here, so we're actually going to be running MobileNet. MobileNet's the same thing as ResNet for our purposes. You basically give it an input image and then you label it as a knot. I forget what that's called. I'm going to call it I won't even call it something. I'll probably get it wrong. And then a quail, right? So predicting an image and running it on Gemini. So again, if you were actually doing this, what would you be doing? You would again do your FireSim run workload. You would see the output log. You would see the IP address and another terminal. You would SSH into it, into that simulation machine. Then you would simulate into the simulation itself, or you would do screen, excuse me, not SSH. And then you would actually see output of MobileNet working. So you would predict the following images. But since we're running low on time, we'll do this actually in the next section, but with extra debugging information. So in terms of results, so anytime a simulation finishes in FireSim, if it finished successfully, it will actually copy the results from that simulation instance to deploy, run results workload, some timestamp, and then the name of the workload. So you have all the results basically stored in a folder. So you can see this currently, if you go to results workload right now, you should see something about Linux uniform, indicating that you ran Linux uniform, and you should see the UART log there, basically any commands that you typed in what you saw on the screen. And then you also have extra information like a config hardware summary, indicating what was the bit stream that you ran it on, what was the configuration, etc. So if you want to go to deploy results workload, you can do that as well. And with that, we'll actually go into the debugging section, which will be handled by Sagar, to talk a little bit about how do you actually debug your simulation.